Hello, I welcome you all in this session of hydraulic machines. In this session, we are going to see the numericals on the reciprocating pump. So this is the numerical. The length and diameter of a suction pipe of a single acting reciprocating pump are 5 meter and 10 centimeter respectively. So length and diameter of suction pipe is given. Length is 5 meter LS and diameter of suction pipe is 0.1 meter. The pump has a plunger of diameter 15 centimeter. Diameter of the piston or plunger is given 15 centimeter. So diameter of piston is 0.15 meter. Stroke length of 35 centimeter. Capital L is 0.35 meter. The center of the pump is 3 meter above the water surface in the pump. So suction head is given HS 3 meter. The atmospheric pressure head is 10.3 meter of water and pump is running at 35 rpm. N, capital N is given 35 rpm. So it is required to find out pressure head due to acceleration at the beginning of the suction stroke. Also, we have to find out maximum pressure head due to acceleration and pressure head in the cylinder at the beginning and at the end of the suction stroke. So given data is written over here. From diameter of the suction pipe, the cross sectional area can be determined. From the diameter of the plunger, its area can be determined. From the rotational speed, the angular speed can be determined in radians per second. So let's try to get answers of these questions. Now first is the pressure head due to acceleration in the suction pipe. It can be given by simple formula. So this formula is coming from the expression of acceleration head in the suction pipe. So HAS is given by LS, length of suction pipe, by G into area of the cylinder or plunger by cross sectional area of the suction pipe into R omega square cos theta. At the beginning of the suction stroke, we know theta is equal to 0. So let's put theta here and cos 0 is 1. So this equation becomes LS upon G into A upon AS into R omega square. We know the value of each term here. Let us put this value and get HAS. The final answer of acceleration head in the suction pipe is equal to 2.695 meter. Now second problem is to determine maximum pressure head due to acceleration in the suction pipe. Now during suction stroke, the maximum pressure head occurs at the beginning because this value is positive. At middle, the pressure head is 0 and at the end of the suction stroke it is negative. So maximum pressure head due to acceleration is found at the beginning of the suction stroke and whose value we have already determined, which is 2.695 meter, which is written over here. The third problem is to determine pressure head in the cylinder at the beginning of the suction stroke. Now at the beginning of the suction stroke, here when theta is 0, the pressure head is the summation of HS and HAS. HS is suction head and HAS is the acceleration head in the suction pipe. So at the beginning, total pressure head is HS plus HAS, which is shown here, HS plus HAS, that is 3 plus 2.695, and the answer is around 5.695 meter. Now if you see, this pressure head is below the atmospheric pressure head line. So commonly this pressure is negative pressure. In terms of absolute scale, we can determine this pressure by the absolute pressure head in the cylinder at the beginning of suction stroke equal to H atmospheric pressure head minus this pressure. So atmospheric pressure head minus HS plus HAS will be pressure head at the beginning of the suction stroke in absolute pressure scale. So its value becomes 4.605 meter of water. Similarly, pressure head in the cylinder at the end of suction stroke. So from this figure, at the end of suction stroke, the pressure head becomes HS minus HAS. So this pressure from B dash to F. So this pressure head is HS minus HAS. Its value is 0.305 and this pressure is also below the atmospheric pressure line. So this pressure is below the atmospheric pressure line. So in order to find out it in absolute reference scale, we have to subtract this value from 10.3 meter of water. So 10.3 minus this value becomes equal to 9.995 meter of water, and that is the absolute pressure reference scale.